Welcome to session 22, Triangle and Exterior Angles. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to use the 180-degree interior angle sum to find missing triangle angles. Apply the exterior angle theorem as a direct shortcut. Solve triangle angle expressions and check that every interior angle is positive. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. An exterior angle equals the two remote interior angles. The triangle markings add side and angle information. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. A triangle with remote interior angles 47 degrees and 63 degrees has exterior angle 110 degrees. The adjacent interior angle is 70 degrees and 47 plus 63 plus 70 equals 180 confirms both relationships. A triangle's interior angles total 180 degrees. An exterior angle equals the sum of the two remote interior angles, giving a direct route that often avoids an extra step. Trust markings and stated relationships, not visual appearance. Diagrams are communication tools, but they are not guaranteed to be drawn to scale. Now add a precision check. Write each relationship beside the diagram before forming an equation: equal, complementary, supplementary, or full turn sum. Preserve degree units, solve the algebra, and substitute the value back to confirm every angle is positive and every required total is satisfied. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, label all known interior angles and any exterior angle clearly. Second, for an interior unknown, subtract the other two angles from 180 degrees. Third, for an exterior unknown, add the two remote interior angles or use its linear pair. Finally, verify that the three interior angles total exactly 180 degrees. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A triangle has remote interior angles of 50 degrees and 60 degrees. What is the exterior angle at the third vertex? Step 1 is to organize the information. Label all known interior angles and any exterior angle clearly. Step 2 chooses and sets up the relationship. For an interior unknown, subtract the other two angles from 180 degrees. Step 3 carries out the mathematics. An exterior angle equals the sum of the two remote interior angles. 50 plus 60 equals 110. A useful check is to interior triangle sum is 180. Exterior angle adds the two remote interior angles. The answer is 110 degrees. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A triangle has remote interior angles of 48 degrees and 77 degrees. What is the exterior angle at the third vertex? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 125 degrees. An exterior angle equals the sum of the two remote interior angles. 48 plus 77 equals 125. A useful check is to interior triangle sum is 180. Exterior angle adds the two remote interior angles. Use this coaching check as well. Use the exterior angle shortcut and the full interior sum as two independent ways to check the same diagram. Session recap. First, label all known interior angles and any exterior angle clearly. Next, for an interior unknown, subtract the other two angles from 180 degrees. Then, For an exterior unknown, add the two remote interior angles or use its linear pair. Finally, verify that the three interior angles total exactly 180 degrees. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.